Hello, today I'm going to talk about concurrency in Go. This is the first video in the series and I would like to publish some videos on this topic, which is concurrency and how we can implement concurrent applications in Go. So first start with the fundamentals and understand what is the difference between parallelism and concurrency. So as you can see in this picture here, we have a concurrent section and we have a parallel section. In concurrent section, as you can see, we have one coffee machine which is serving two queues of customers. And in the parallel section, we have two coffee machines, 1 plus 1, and we have two different queues of customers. You can consider this one coffee machine as one core, and you can consider these two coffee machines as two core. One core is this one and one core. So we have we used to have single core machines, but now we have dual or multiple core machines. So if we have a process, so these two are independent processes trying to accomplish their task using this machine. In the same way, Go concurrent applications, we have different processes, or we can say we have different Go routines which try to execute their task, and they use multiple codes or single code to execute their task and to complete their work. Now this is a very brief introduction and a very brief difference, and now let's see how we can implement a simple concurrent program in Go. Now here I have this Visual Studio code, and I will write a very simple program, and then we will convert that program in a concurrent application. So let's write the first function. I will say func main. Let's first write the main function, and this main function will call another function. We will say func print something, and I will create a separate function func print something, and we will get a parameter. Let's say we will say this print something will get a value which will be of type string, and here we will simply say fmt dot print, and we will print the value. Okay, and from here let's pass some value. That value can be 1, and let's call this 2 times, and this is 2. And to make this function a little bit more interesting, I'm writing an infinite loop here. So this simple print function is in an infinite loop, and this loop will keep on going. And let me write a sleep statement dot sleep, and here I will say time dot millisecond multiply by 500. Okay, a very simple program, and very nothing is there. So let's run this. Go run dot. Okay, sorry, we don't need to write the func here, we're just calling it. Okay, silly mistake. Okay, 1 1 1 1. So 1 is getting printed but not 2. Why? Very simple explanation, because as the first function is called, this one is in an infinite loop, and the second function will not even get the chance to run, right? So how we can do it, what we can do it? So how we can run this function so that we could execute both the functions? One way is we can create, and we can write Go in front of this first call, and then this first call will run in a background, and this second method, the second call, will also get the chance to execute. Let's run this program now. Let me save this, and I will say go run dot. Okay, as you can see, we have both the numbers printed 1, 2, 1, 2. So now what actually happened? Let me try to explain. So we have a main method, and this main method, this is a timeline of the main method. When we execute the program, the main method runs. So this main method is running, and then we call print something with a go keyword, right? So here we have the go keyword, and we execute this function. So for example, at this point, we called the go print something, and the print something started to work, right? In its own process. It's an independent process, an independent method which is now working and doing its work. With that, we also have, so this one is printing 1, right? This will keep on printing 1. And we also have another method which is the part of the main method, which is also print something. But this one, and this one is printing 2. This one is printing 2. Now, the scheduler, the go runtime is actually printing both of these messages. And since the print something is running in its own process, and main method is also running, it's in own process, so nothing is happening and everything is going good. But there is a catch here, and the catch is, what about if the main method is terminated or stopped? When this is stopped, then this go print something will also stop. Why? Because this is a part of the main method. So the print go something is not completely independent. This is actually somehow dependent on the main method. If main method is terminated, then this go routine will also be terminated. So this is called a go routine. Go routine. We will look at this go routine more in details further. So let's come back to the code. Now let me change the code a little bit and see what happens. I have written go for both of these two methods, right? And this means they will run independently of the main method. And so what we are expecting, will they work same as we saw just before? Let's see. Let me save this and execute once again. So nothing is happening. So what is going in the background? Let me show you. So what we have a main go routine, a main function, which we can also call a main go routine. And then this main go routine triggers or executes the print go, which is printing 1. So this is the print 1. It starts this method. And then it also starts another method, which is this one. And it is executing. So both of the methods, both of the go routine have started working. Both of the go routine have started working, but the main method actually has finished, right? Because there is nothing in the main method to do. So the main method has finished. Since the main method has finished, this this go routine, which is printing 1, and the second go routine, which is printing 2, has also terminated or has also finished. Now, is this the correct behavior? I feel no, this is not a correct behavior, because we wanted to execute this print method and we wanted to perform some actions, but the main method has finished. So what we can do something like wait. We can call, instead of the main method getting terminated, we can say something to the main method that please wait because my go routines are in process, and wait until I finish my work. So for example, they are working, these both go routines are working, so you please wait. So it's actually in a waiting state, and once we finish the work, for example, we have done, so this is, we can say work done, and then we can notify the go routine, the main go routine, that okay, I have finished, now you can also finish Now you can also finish the main Go routine. We will see how we can implement this in the next lecture.